Hai, Assalamualaikum. My name is Mohd Ikhwan bin Mohd Hanafiah. My metric number is 2022800458. I am from class AAP266B. This is my individual assignment. For the first test is rebound hammer test. And how it works. The rebound hammer test is a portable device used to assess the compressive strength of hardened concrete or rock surface. Its operation is based on a simple principle, which is when the hammer strikes the concrete surface, a spring-loaded mass inside the hammer impacts and rebounds. The rebound distance, measured as a numerical value, correlates with the hardness or compressive strength of the material. Factors such as surface hardness, roughness, moisture content, and the age of the concrete or rock can influence the rebound number. Calibration ensures that these variables are accounted for, providing a reliable assessment of compressive strength in a quick and non-destructive manner. Next, list of equipment used. For the first one is rebound hammer, grinding stone, ruler, and the last one is marker pen. For the specific for rebound hammer is the model, certificate number, serial number, and the company that provide these machines. For the features and application, the first one is features. It is portable. It is lightweight and handheld, making it easy to carry and use on site. Next, non-destructive. Provide a non-destructive method to estimate compressive strength without damaging the concrete or rock surface. Simple operation. It is require minimal training to operate effectively. Spring mechanism. Utilize a spring-loaded mass that impact the surface and rebound to measure hardness. Calibration. Come with a calibration chart specific to different type of concrete or rock, ensuring accurate measurement. For the last one is versatile. Can be used on horizontal, vertical, or overhead surfaces. Application. Quality control in construction. Assess the quality and uniformity of concrete in structure like building, bridge, and pavement. Next, strength evaluation. Estimate the compressive strength of concrete or rock surface during construction on or after hardening. Damage assessment. It identifies areas of potential weakness or deterioration in existing concrete structure. Research and development. It is used in research to study the property of concrete and its behavior under different conditions. Maintenance and inspection. It is monitor the condition of concrete over time and to plan maintenance and repairs. For the last one is forensic investigation. Assist in forensic investigation to determine the cause of structural failures. Limitation of rebound hammer. For the first one is surface sensitivity. The test is only indicative of the surface hardness and surface conditions, such as moisture content, texture, and carbonation. It can affect the result. The second one is correlation limitations. The correlation between rebound number and compressive strength is not always straightforward and can vary based on concrete mix, age, and other factors. The procedure of rebound hammer test. For the first one is calibration. Before use, ensure the rebound hammer is calibrated according to manufacturer instruction and the specific type of material being tested. The calibration ensures accurate readings. Preparation. Prepare the surface by cleaning it of loose particles and debris that could affect the rebound measurement. Next is positioning. Hold the rebound hammer perpendicular to the surface being tested. For horizontal surface, ensure the hammer is stable and does not rock during testing. Impact. Press the plunger firmly against the surface and trigger the release mechanism. The hammer will impact the surface, causing the spring-loaded mass to rebound. Measurement. Observe and note the rebound distance indicated on the scale of the rebound hammer immediately after impact. And then recording. Record the rebound number displayed by the hammer for each test location. Multiple reading. Take multiple reading at each test location to account for variability and ensure accuracy. Typically, 8 to 15 readings are taken per location. Analysis. Use the average rebound number obtained from the multiple reading and refer to the calibration chart provided by the manufacturer to estimate the compressive strength of the concrete or rock. Interpretation. Compare the average rebound number to the compressive strength value indicated on the calibration chart to assess the quality or strength of the material. For the last one is report. Document and result and findings, including the location of test, average rebound numbers, and corresponding estimated compressive strength. Next, test 2, ultrasonic pulse velocity test, which is UPV test. How it works. The ultrasonic pulse velocity method assess the quality of materials like concrete by sending high-frequency sound wave, ultrasonic pulse, through them. It works using two probes, one sends the pulse and the other receives it after it travels through the material. The time taken for the pulse to travel between the probes is measured, and from this, the velocity of the pulse is calculated. This velocity depends on the material's density and elastic properties. Higher velocity typically indicates stronger, denser, and more homogeneous materials. UPV is widely used in construction to check the quality of concrete, assess the structural integrity, and detect potential issues without damage the material itself. The list of equipment used. For the first one is UPV test machine, transducer, and the last one is calibration rod. For the specific is model number, model name, year made, and the company provide this machine. The features and application. The first one is non-destructive, does not damage the material being tested, making it suitable for assessing existing structure. Versatile, can be used on various construction materials like concrete, rock, and masonry. High accuracy, it provides precise measurement of pulse velocity which correlate with material properties. Portable equipment, it is typically UPV devices are portable and easy to use on site. Fast result, it delivers quick result, enable rapid assessment during construction or inspection. The last one is depth penetration, can assess material integrity at greater depth depending on the equipment and conditions. The limitation of UPV. For the first one is surface preparation. It requires smooth and clean surface for accurate measurement. The last one is interpretation. Interpretation of result may require calibration against known standards or previous test data. The procedure of UPV test. For the first one is setup. Place two probes on opposite side of the material, which is concrete. Apply a coupling agent between the probes and the surface for better contact. Measurement. Emit an ultrasonic pulse from one probe. The second probe receives the pulse after it travels through the material. Timing. Measure the time it takes for the pulse to travel between the probes. And then repeat. Take multiple measurements at different spots to ensure accuracy. Calculate. Use the average time and the distance between probes to calculate the pulse velocity. The last one is interpretation. Compare the pulse velocity with standard or previous measurement to assess the material's quality and integrity. The last test is half cell test and how it works. The half cell potential test assess the likelihood of corrosion in reinforced concrete. It involves placing a reference electrode on the concrete surface and measuring the electrical potential between this electrode and the embedded steel. A more negative potential indicates a higher risk of corrosion. This non-destructive test help identify potential corrosion area early, enable proactive maintenance to prolong the structure lifespan. The list of equipment and details. For the first one is weighing scale, beaker, spoon, rebar scanner, digital multimeter, distilled water, copper sulfate, and the last one is electrode. For the specification is model number, model name, certificate number, year made, and the company that provide this machine. For the features and application, it is non-destructive, does not damage the concrete or steel being tested, allowing for frequent assessment without structural harm. Quick assessment provide rapid result, making it efficient for evaluating large area or structure. Early detection detect area at risk of corrosion before visible signs appear, enabling proactive maintenance. Portable. This equipment is typically lightweight and portable, facilitating on-site testing in various locations. For the last one is cost-effective. Offer a cost-effective method to monitor and assess corrosion risk compared to more invasive technique. The limitation of studies. For the first one is smooth surface for testing, size, shape and rigidity of the concrete, age of concrete, surface and internal moisture condition of concrete, type of cement, and the last one is carbonation of the concrete surface. The procedure of half cell test. The first one is preparation. Clean the concrete surface to remove any dirt, oil or loose debris that could affect the test result. Setup. Place a reference electrode, typically copper sulfate electrode, on the concrete surface. Ensure good contact. Measurement. Connect the reference electrode to a voltmeter and measure the electrical potential between the electrode and the reinforcing steel embedded in the concrete. Recording. Record the measured potential at each test location and on the structure. Analysis. Interpret the result based on the voltage readings. A more negative voltage indicate a higher risk of corrosion. Compare reading to established criteria or standard to assess corrosion likelihood. And then repeat. Take measurement at multiple locations across the structure to assess overall corrosion risk comprehensively. For the last one is documentation. Document the test result including location and corresponding potential value for future reference and analysis. Okay, for the conclusion, in summary, the rebound hammer assess concrete strength, the ultrasonic pulse velocity test evaluate material integrity through sound wave speed, and the half cell potential test identify corrosion risk in reinforced concrete. Each test provides essential data for maintaining infrastructure durability and safety, aiding in construction quality control, defect detection, and proactive maintenance planning. Together, they support comprehensive management of the structural integrity from initial assessment to ongoing maintenance, ensure long-term reliability and sustainability in construction practices.